So again, continue with special products, chapter 13. Again, when question 2 says, determine whether the expression is a difference of squares. So is the first term a perfect square? Now, let me pause a moment and get my calculator out here. So what we're trying to figure out is what square gives me this 169? One thing you can do is use the inverse of squaring, which is the square root button. So if I type in the second button, hit the x squared button, I can type the 169 in. So it gives me the square root of 169. If I hit enter, if I get a whole number, then it's a perfect square. So that tells me the 13 squared is 169. And I can verify by hitting 13 and hit the x squared button, hit enter, and that does give me 169. So the 169 is a perfect square. It's going to be 13 squared. And again, oops, don't need an equal sign. The other thing we look at is the 81 part of it. Is 81 a perfect square? So again, if we take the square root of 81, so the square root symbol is above the x squared, so I got to hit the second button first, square root of 81, so it should look like this on your display. Hit enter, it gives me 9. So that does mean 9 squared does give me 81. Now, it's not a bad idea to go on the internet and just print out a list of table of squares, but your calculator can also do a table of squares. So if you hit the y equals button, and then let's turn off this plot here. We don't need it at this time. So if we type in this x, which is right next to the alpha button, and if we square that, this creates a formula, y equals x squared. And right above graph this table, and this allows me to generate a table. So if I second button, hit the graph button, it'll actually do the table button above. So what this is doing is this is what we're squaring, and then these are the square results. So 0 squared is 0, 1 squared is 1. So notice that these are perfect squares. But typically we start with like 4, 9, 16, 165, 36, 49, 64. Notice that 81 is a perfect square. And this to the left tells you what was squared to give you that. So if I scroll down a little bit further using my directional pad, notice there's that 169. Notice that tells me the 13. So you actually just type in y equals x squared to generate a table, if you will. And then you can see a table of squares, or you can go out on the internet and get one. So notice that the 81 is a perfect square. So that would be 9. And notice that we need a p. If I square that, that's going to allow me to get that 81p squared. Now, to be a difference of squares, though, there's got to be a minus sign here, but what's up here is a plus sign. So we're really close, but this is not a difference of squares. This is a sum of squares. So I should have paid attention that right off the bat, this should have been a minus sign. It failed right off the bat because this was not even a subtraction between two binomials, or two monomials, I should say. So this was not even a subtraction symbol. A difference of squares, you have to have this a squared minus this b squared equals this a minus b times a plus b. But since this did not hold true, then we cannot do this. So this is dead in the water. This is not a difference of squares.